Can you all see my screen now? I hope you guys can you have access to the screen.
Yes, sir.
Yeah. Yes.
Thank you. All right. So yeah, being an online course, I think I didn't want to stretch too much in terms of time, and I know that it's like weekend is always a family time. But once again, thank you for the participation. It means a lot because it's good to see that a lot of people are interested in learning about weather and climate dynamics. So what we will do is we will have some breaks in between. Of course, I had shared the schedule, so we'll try to stick to the schedule as much as possible. And what I want to do is, so this is just a first slide which I want to put out, that all the images that I have taken or that are presented in this talk are taken from websites or the NOAA website or NASA websites or some books, weather-related books. Or the satellite images from various meteosite satellites, Euromet satellite, those places. So since I'm using it for education purposes, I just want to claim that there is, I mean, I'm not trying to plagiarize anything. So this is just a disclaimer that I need to put. So before we get started with the actual course content, so this is something that I did last time also when I offered the course. It may be a good idea to note down some questions that you have, because I'm sure that there are many questions surrounding weather dynamics or weather patterns or weather systems. So if it is possible that we note them down and see if we can answer those convincingly over a period of the next 2 days that we will be interacting. So if anyone has any question, we can I'll just note it down and see if we seamlessly answer them through the slides that I have. So this is kind of what do you call, whether checking whether the content that I have prepared and whether what you're expecting does it actually meet at some point. So because I don't know what kind of questions you have and you don't know what presentation I have made. So this would be a good way to gauge whether we have somewhere we are converging rather than diverging. Okay, so maybe the next couple of minutes I'll just hand over to you guys. If you have any questions, please let me know. I'll just write it down, and then as and when if I'm able to answer through these slides, I'll just pinpoint that okay, this question has been answered, this has been answered, and those kind of things.
Yeah. Professor, can I go first? My name is Srinivas Kalyan.
Yes, please.
Yeah. We say weather is unpredictable, but we also want weather as an input for various assessments and all that. How do you match these two, almost dichotomous, statements? On one hand, we say it is unpredictable, so therefore predictability or reliability is low. On the other hand, we want to use it as a variable for various decision making or decision inputs. So how do we balance this?
Yeah, okay. So I have noted it down, and I'm sure that there is maybe today itself that question may be answered. So yeah.
Sir, can I ask, sir?
Yes, please go ahead.
Sir, about southwest monsoon, I have one doubt, sir. Does the topography of India, that's like above Vijayawada, the Bay of Bengal coast is curving more eastward, sir, so that southwest monsoon is getting more active in northern parts of Odisha and all, sir. Is it correct, sir?
Okay, I have noted it down. We'll try to answer it when we talk about Indian monsoon tomorrow. Yeah.
So this is Makarand. I think basically two questions. Obviously, learning to, looking forward to learning more about monsoon, and there are hundreds of questions. So I'm not going to really put those questions. But my specific question is the monsoon typically only an Indian phenomenon, or monsoon also happens elsewhere in the world? And if yes, what are the differences?
Okay, all right. Yeah, all right. That's a interesting question. Yes. So maybe when we talk about Indian monsoon, we will touch upon that.
Thank you.
The simple answer is I think it's not only Indian phenomenon. It happens in other places as well. So I'll talk about it when I get there.
Okay.
Sure. All right. So maybe that I've written 3 questions so far. As and when if you have any question or any comments, you like I said, just unmute and let me know so that I can stop the presentation and we can take that question. Okay. Okay. So that's that's a pretty good start. All right. So since it is a basic course on weather dynamics, I'm not sure how basic it is as of now. In the sense that there may be some advanced concepts which require a little bit understanding of engineering and physical dynamics, but we will try to make it as simple as possible so that everyone can get a feel for the basic element of weather. So when I talk about the basic elements, then these are the points. I mean, these are the variables that I talk about mostly. Okay, so there is pressure, there is wind, temperature, moisture. Circulation is basically how the circulation patterns develop over ocean or over the land. And then you have solar insolation, because without sun's energy, there is absolutely no chance that we can get convection. So we'll touch upon that. And all these, the first 6 parameters that I have mentioned are the intrinsic parameter, in the sense that they are the ones that control the weather. And then the next 4, clouds, rain, instruments, and models, those are the extrinsic parameters, which actually are the outcome. So clouds are an outcome of how pressure, wind, temperature, moisture, and solar insolation behaves. Then once cloud form, then you have rain. Then you have instruments to measure these 6 top parameters that I have mentioned: pressure, wind, and all those things. And models are also used for forecasting these basic elements of weather, which are the top 6 parameters are the basic elements, these 6. Okay. So in the next 1 hour or so, what I'll try to do is we will talk about these 6 parameters, and then we will try to understand how they actually play a role in governing the weather patterns. Okay, so I wanted to start with pressure because I feel like everyone can associate with this particular thing, because whenever you, I'm sure at some point of time, all of you must have taken a look at any bulletin or any weather chart at least once in your lifetime. And whenever you look at those charts, the pressure is the most important aspect that you all look for. Like, where is the L, which is the low pressure? Where is the H, which is the high pressure? So pressure is probably one of the most important aspects of meteorology, at least if you ask any fluid dynamicist, okay, like me. To me, pressure is one of the most important aspects and one of the most difficult parameters to forecast. Actually, it is one of the most difficult parameters to forecast, because a lot of uncertainty is associated with measurement of pressure. Okay. And we talk about these high pressure, low pressure systems, and we still don't know how they form, when they form. The dynamics are very complex, so we'll talk about those in the upcoming sessions. What is the basic mechanism by which these low pressure, high pressure forms, and what are the winds? How do the winds behave during these low pressure and high pressure systems? Okay, so those are the important aspects of pressure, because pressure governs the wind patterns as well. So the best example is a cyclone. If the cyclone pressure is very low, then winds are very high. So there is absolutely there is a definite correlation between winds and pressure. That makes pressure one of the most important variables. Okay. And when you talk about pressure, if you are interested in, let us say, forecasting weather as a hobby, not as an official meteorologist would do, then if it is a hobby, if it is being looked at from a hobbyist viewpoint, then the most important aspect is surface pressure. Okay. And when I say surface pressure, then I mean, let's take the chart that I have shown in my background. That is a typical surface pressure chart. Okay, and it tells a host of information, because those lines that are connecting, so you see these undulating lines which are moving up and down. Those lines are called isobars. Isobars are the lines which connect the points with the same pressure. Okay, and those lines tell you a lot of information, because they say where the pressure is low, where the pressure is high. And one of the important advantages of the surface pressure chart is that it is easily measurable using a weather station. So you deploy various weather stations at different locations, okay, and you measure the pressure using barometric pressure gauges or using pressure sensors, okay, and you will have recorded many pressures at many locations. So measuring pressure over land is easy because you can easily deploy these weather stations over land. But getting these pressure measurements data over ocean is not very easy because you have to put buoys or you have to put some floating structures in the ocean. But nevertheless, if you can deploy a lot of these pressure sensors, then actually you can get a very nice surface pressure chart. And what I am looking for in these surface pressure charts is this L, which is these symbol which is denoted by L, which is the low pressure. Okay. And whenever I see that L, then I know that there's a low pressure forming. Then the next thing I look at it how the low pressure is moving. So which direction it is moving. That's when the aspect of wind comes into picture. Okay. So this particular surface pressure chart is updated very frequently, and this is not forecast. This is not a forecasting chart. This is a chart which is obtained by putting data from different satellite images or different weather stations that are there. And this is available from the Thai Meteorological Department website. I will in tomorrow's session, afternoon session, when we have that 1 hour of weather forecasting tools, I will show you where to access these charts. Okay, so right now don't worry about that. Surface pressure chart is very important because upper level measurement. So you cannot deploy sensors at, let's say, 5 kilometers above the ground. That's why surface charts become very important. So one important aspect of surface pressure chart that you should understand is that if you recall your class high school physics, then you know that the pressure decreases as you go in altitude. So as I keep moving up, the pressure reduces, right? That's why when you fly in an aircraft, your cabin is pressurized so that you feel you feel the same pressure as on the ground. Okay, the reason is because outside pressure is lower. Okay. So this actually tells me that let's take an example of Mumbai and Pune. The reason I'm taking that is because it's easier for me to connect. Mumbai is at an elevation of 100 meters. Pune is at an elevation of close to 750 meters. So this elevation difference automatically gives a pressure reduction, correct? So Mumbai, since it's at 150 meter elevation, it will have high pressure, whereas Pune will have a low pressure just because of the pure altitude difference in the pressure. Okay. So that automatically means that the air should only flow from Mumbai to Pune because high pressure to low pressure is where the air moves. Okay, but that is not true because that doesn't mean that air cannot flow from Pune to Mumbai. Okay, because what we are only assuming is that we are only assuming the base state, which is with altitude pressure decreases. Okay, so all these recording stations, no matter where they are located, okay, whether it is in Mumbai, whether it is in Pune, whether it is in Mahabaleshwar, doesn't matter, wherever the recording station is, all the values at that recording station are referenced to the mean sea level, which is 0 meters. Okay, so I take all the values and I bring it to the mean sea level value, and then I compare all the pressure values. So these chart that I have obtained are all referenced to the mean sea level pressure. That is actually the best way of saying whether a low pressure has formed or high pressure has formed. Okay, because that neglects this base state, which is going to which is actually going to be a noise in the data, because this particular physics which we cannot control clearly tells me that any location at a higher elevation will have a low pressure, but that's not true because here what we are talking about is the pressure reduction due to the warming of the air or due to the movement of the air. That is what we are talking about. Okay, so that particular pressure can change with elevation. So it's highly possible that although Pune is at an elevation of 750 meters, it can have a high pressure, and Mumbai can have a low pressure. So winds can move from Pune to Mumbai. Okay. So that is very important. Whenever you are plotting surface pressure charts, you have to reference it to the mean sea level, right? That is as far as the pressure goes. Temperature and wind, if you look at temperature and wind information, that is no way normalized because so every point on this particular line, although this is a constant pressure line, for instance, this particular line that I have drawn, this red line is a constant pressure line, but at every point on that line, the temperature and wind could be very, very different. So these are, although pressure is the same, but the temperature and wind speed will be very different. And that has different connotation because if I have a colder wind, if I have a colder air mass, it will behave differently. If I have a warmer air mass, it will behave differently along the same pressure line. Okay, so you can see that even although I'm talking about a very basic system like a pressure, but the complexities keep adding up because even on those isobars, which are the constant pressure lines, you can have different temperature, so you can have different temperature of the parcel and different wind information. So one of these parcel on this constant pressure line might be moving faster than the other, and that can give rise to different dynamics. Okay, so surface pressure charts are very important, but at the same time, they are not only thing that we can rely on to get a very accurate information about weather. Right, so that is one important aspect. Okay, so nevertheless, if I don't believe in models, for instance, I say that the models are actually not something which are very accurate. Then what meteorologists or what people who understand dynamics, what they like to do is they just like to look at the surface pressure chart, okay, and then they deduce things 2 to 3 days ahead of time. Okay, so let's say I have this surface pressure chart as of today, which is December 19th, around 10:30 a.m. This is the chart that I have received. Using this surface pressure chart, I can actually understand what would happen in the next 6 hours or 24 hours. Okay, so a lot of people actually just want to look at the surface pressure chart because it gives a lot of information. Sorry, it gives a lot of information, which is whenever I have a low pressure system, okay, whenever I have a low pressure, that means the winds are going to converge because the low pressure means it is a column of warm air which is rising upwards. So to fill that void, air from different regions will come in and they will fill this particular void. Right. So the kind of pattern that I have is I will have at 1000 millibar, which is ground, I will have a surface pressure with surface low pressure system. Okay. And to compensate for this low pressure system, I should have high pressure somewhere else because as this air is rising up, it should move to some place and then go out. Okay. So there is convergence and there is divergence. So at low level, if there is a convergence, then at high level, there has to be a divergence. Then only continuity of mass will be retained. So then only air will flow. That is the property of air. We cannot stop that. That is how nature works. Because something is converging, it will get uplifted because there is ground. As something is coming to the ground, since it is solid surface, nothing can penetrate the ground. So it can only move up. As it moves up, it encounters a high pressure zone. It moves out. Okay. And the divergence for this high pressure is a convergence for the next low pressure system which has formed here. Okay, so I hope I am clear. And then as soon as this diverges, then this low pressure system will push it down, and then there is another high pressure. So this is how actually a surface pressure chart looks. Any low pressure on the ground, okay, any low pressure on the ground will be surrounded by two high pressures on each side of it. Okay. And any high pressure on the top, which is upper level, which is 500 millibar, it will be surrounded by two low pressure systems on the side. So these low pressure systems are not very conducive because they don't help in formation of clouds. The one that actually we are on the lookout for is this particular guy. We are always on the lookout for a surface level low pressure system. Okay. And as soon as I see that, I know that, so then I look at the value because the value is important because if the pressure is very low, then actually it can sustain for a very long period of time. So what meteorologists actually do is they look at the surface pressure chart and they look for these values of L. And as soon as they see L, they see the value of that. Okay, so if the normal pressure is 1000 millibar, a low pressure would mean that it is, let's say, 990 millibar. So they look for the value of this, whether it is 990 or 970. If it is 990, 970, very low values, that means it's a very strong system, and there is a chance that it will actually linger for a very, very longer time. Okay, so what I'm trying to say is a pressure chart is a very, very useful tool because from that you can actually make out a lot of things. And what I am going to look for when I see a surface pressure chart is I'm going to look at this low pressure, whether it has formed or not. I don't care about these, because as soon as this is there, this will automatically, the physics will automatically make this happen. Okay, at the upper levels. Okay, so surface pressure charts are very important because it's easily accessible. Like I can measure things by using weather stations. So the next question is populating the land or ocean with lot of weather stations. That is going to actually help us a lot. Okay. So the next thing that is telling me is that, so I told you about these two pressure levels, 1000 millibar and 500 millibar, two levels. So the air column between these two levels, okay, can actually be warmer or colder. Okay. So what other thing that I'm looking at is I'm looking at the difference in the height between these two pressure levels. Okay. So so what you will actually see is some places the height is smaller and some places the height is higher. Okay. So lower height means colder air, higher height means warmer air, and that automatically means that this is a low pressure system and this is a high pressure system on the surface. Okay, this is a low pressure, this is a high pressure. Why? The reason is straightforward, because this warmer air is going to move, it is going to mix, and it is going to form, it is going to aid in formation of clouds. And we all know that clouds have cold air in it. Okay, because they are they condense and they get into they get into dewdrops and they are colder. Okay, that is why the cloud will form and it will ensure that this is the height is smaller. The difference between 1000 millibar and 500 millibar height is smaller. Okay, higher height would mean that it is a high pressure zone. Okay, so this is the other thing that I am actually going to look for in my sample pressure charts. So I have, what I'm showing here is from IMD website. I have taken two charts. One is at the 1000 millibar level, other is at 500 millibar level. And how to know the difference? How to know the difference is very straightforward. I look for these ridging and troughing patterns. So ridging and troughing pattern means this upward pattern of wind, upward pattern of pressure, and this downward pattern of pressure. Okay. So when this is an upward pattern of pressure, I reference it with this location somewhere here, and I see that this is lower, this is higher. So that automatically means that this is going to be a high pressure zone because the difference is going to be high. Okay. I hope I'm clear, right? Because if this is if the pressure at surface is going to dip, and if the pressure at 500 millibar is going to move up, that means that this height is going to increase. Okay. Whereas if this 500 millibar line is going to dip down, that means that the height is going to reduce. That means that there is a chance of low pressure formation. That's what exactly has happened. There is a low pressure which has formed here. See, the other thing that you have to recognize is these things are not one-to-one correlated, in the sense that as soon as it tips, that doesn't mean that a low pressure will be here. A low pressure will be in the vicinity, somewhere in the vicinity of this particular zone. And that's exactly what we see. There is a low pressure in the vicinity of this zone. Okay, and this is what happened in Mumbai on December 14th, 13th, 12th, 13th, around that time, when you had a lot of rain, because there was this cloud formation, and that also led to unseasonal December rains, which we all realized on December. I think many places in Maharashtra it actually rained. Okay, so if somebody tells me that I can only give you one chart, okay, then I would actually opt for pressure chart, which is at the surface, and if possible, if they can also give me the 500 HPA chart, which is the upper level pressure chart, then actually I can deduce a lot of things. And you can see that since this is a warmer air, so this column is so between this point and this point, the height is higher. Okay, so this means that it's warmer air, and I can show you that it will have clear skies. See, nothing, clear skies. The second thing that I would like to point to you is that here also there is a dipping pattern. Okay, so this dipping pattern means again there is a low pressure, because the difference in the height between 1000 millibar and 500 millibar has reduced. That means there is a inclement weather which is approaching, and that is exactly what you see here. This was snowfall that was realized in Jammu and Kashmir and Himachal last week. Okay. So what I'm trying to say is, actually just by looking at pressure charts, we can have a lot of information, and this is one thing that I find very useful. And of course, I cannot go. I cannot predict 7 days ahead of time. Okay, let us say I get these two charts today. Next 24 hours, what is going to happen? I can confidently tell with 95% accuracy. I can tell what is going to happen. Okay, this long-term forecasting, which is 7 days, 10 days, 15 days ahead of time, that is what is going to happen. That is not possible using these charts.
Sir, excuse me, sir.
Yes.
Sir, does that if the height is high means it's low high pressure, no, sir? Can you please
Yes.
tell with the chart one more time, sir?
See, so these are two pressure lines. One is the 1000 millibar, another is 500 millibar. Correct. So I have these two pressure charts, which is 1000 millibar. This is at 1000 millibar level, which is the surface level, mean sea level. Okay, this is MSLP is mean sea level,
Okay,
and this
sir.
is the 500 HPA, which is 5 kilometers above the ground. Okay.
Okay, sir.
So what I see is that there is a dipping. So when this 500 HPA charts rises up, so when there is this bridging pattern or when it is elevating upwards, then that automatically means that between 1000 millibar and 500 millibar, the gap is going to increase. Correct?
So are you telling it in movement towards northward direction like that? Are you telling, sir?
Yeah. Movement was northward direction, but let's not make it complicated. Let us just say that. See, so I don't know if I can use the pen. Yeah. So let us say this is 1000 millibar and this is 500 millibar. So this is what I'm talking about. As soon as the 1000 millibar dips and 500 millibar rises up, then this gap is going to increase.
Yes, sir.
As when this dips down and this remains the same, let us say, this gap is going to reduce. So this
Yes,
tells me
sir.
that this is a high pressure zone and this is a low pressure zone. That's exactly what I'm trying to
So
find from these pressures.
so more gap means it's a high pressure, no, sir?
Yes, more gap means high pressure. Correct. More
Okay, sir.
gap between the 1000 millibar and 500 millibar pressure lines, isobars.
Okay, sir. So this 1016 is the 1014. These are coming close in China, so it's high pressure, no, sir? No, low pressure.
This one.
Yes, sir.
Yeah, this one, yeah, you should see. So here, as soon as you come here, it is kind of flattening out. So this is probably nothing. I mean, this is high pressure, or this is a low pressure, correct? Because the distance will be higher. So between this and so in this region also, you probably would see some clouding. Not, yeah. So you see some clouding here. See, is it clear?
So if it's come closer means it's low pressure, and it goes away means high pressure. Correct, no, sir? Those lines.
Yes. Correct.
Okay, sir.
So I have a quick question. In the chart on the right, the numbers indicate the height at which the pressure is 500 millibars. Is that right?
Yeah, so this is basically the pressure at 5 kilometer, and these are not pressure values. This is known as the height. So this means that
Got it.
it's a good question. So this is a proxy for pressure. Okay. So
Okay.
what this means, 5850 means the air parcel is at a height of 5.8 kilometers from the ground, and 5640 means the pressure the parcel is at a height of 5. Sorry, so not 5.8, sorry, 10 minus 5.8, so 4.2 kilometers from the ground.
Oh, okay.
And this means that this is at a height of 4.4 kilometers from the ground. Okay. So what this means is higher values means this. So as these actually ridge up, okay, these values actually ridge up. This means that these are warmer air, okay, and this is colder air, because the height of height of the column indicates cold air versus warm air, because warm air has the tendency to rise up more, so it will actually move more to more heights. Is that clear?
Got
See,
it.
cold air is denser, so it will not move to a much larger height, whereas warm air is less dense, so it has the capability to reach larger heights. So that is exactly what you are seeing here.
Okay. Okay. Thank you.
Yeah. So this is a proxy for pressure. Basically, these values are proxy for pressure. But what I am, but I mean, if I go into details, then it may get too technical. So what I'm trying to simply tell is, just try to look at these differences. And the differences are lower, then that means it's a cold air parcel, which means it has a tendency of a low pressure behavior, whereas this has a tendency of a high pressure behavior. Okay. Yeah. So the next thing that you may ask me is why does a pressure become low at a location? Okay, so the pressure becomes lower because of a trough. So this trough is exactly what I showed you, movement of a cold air. So what the movement of a cold air does is it creates an instability because cold air is less dense, more dense. So it will trigger an instability and it will allow the it will allow the air to come down. And as the air comes down, it will actually get heated up because of the laws of thermodynamics, because of compression effects, and that is going to result in the formation of a low pressure. So this trough kind of a system that you always see is always an indication of a low pressure behavior. Okay, so anytime you see this kind of trough, so this trough pattern which is coming in, that means that there is a chance of a low pressure system forming somewhere nearby. On the surface. See, all I'm trying to say is whenever I say low pressure, surface low pressure is what is important because that is what is going to lead to formation of clouds. Okay, so remember this particular diagram. Whenever I say low pressure conducive for formation of clouds, I mean the surface pressure low. So at 1000 millibar, the pressure should be a low pressure. Deepening of the trough makes sense because as the trough is more, it dips further down. It actually has a tendency to make the pressure low. Okay. Evacuation of mass by upper level divergence. So I go back here. So evacuation of mass means when there is upper level divergence, then the mass will actually be deflected. There will be a divergence. So take for example a pipe. The pipe initially is fully filled with water. It has inlet and it has outlet. Okay, from the outlet the water keeps spilling out. That is the evacuation of water that I'm talking about, evacuation of mass. So now to have the pipe fully filled with water, something has to come in, right? Then only the pipe will be filled with water. Otherwise, the pipe will become empty. Okay, so that's exactly what I'm talking about. Evacuation of mass means automatically there has to be convergence because the whatever void has been filled, whatever void has been created, should be filled by air moving from down to up. Okay, so surface pressure can become lower by sudden evacuation of mass at higher levels. Okay, why that happens? It happens because of vorticity, jet streams, jet streaks. That's a completely different phenomenon, which we will talk in the afternoon and tomorrow. Okay, what are the processes by which evacuation can happen? That is a process-based study. Okay, right now we are just looking at how these elements of weather actually behave. That's all. Okay. Moisture advection, which is moist air from ocean coming in, that can also result in a low pressure because moist air is warmer, so it can actually lower the pressure. Warm air advection is same as moist air. So when warm air from one place to the so let's say warm air from one place moves to the other place, the pressure can decrease. Rising air is again related to warm air because warm air rises up. Okay, so these are the 6 ways by which a pressure can actually drop. So we are always on the lookout for one of these 6 mechanisms to find out whether the pressure has become lower or not. So a quick wrap up on pressure decreases as we move up. Hence, we need to normalize to mean sea level. This is very, very important. So if you are actually interested in taking this up as a hobby, and if you are interested in providing weather charts to people, then you have to normalize it to mean sea level. Okay, because otherwise, whatever you are measuring is all wrong. Okay, because the automatic tendency of a pressure is to decrease as you move up. So we have to normalize it to. So we have to bring all the stations to mean sea level and then look at the pressure charts.
Sir,
Surface
one
pressure
question.
chart.
Sir,
Yes.
so they are in apps and all, they are showing the pressure in different locations. No, sir, like in Bangalore,
No,
they are
no.
showing high pressure. So does it mean that it's in if Bangalore is at mean sea level, that's the pressure in that location? Is it like that, sir?
Yeah, so if you are trying to measure pressure in Bangalore, surface level pressure in Bangalore, whatever pressure you measure in Bangalore, you will have to normalize it to the mean. So Bangalore is at a height of 900 meters. So what
Yes,
you will
sir.
have to do is you have to do, so if the value of pressure that is measured there is, let us say, 800 millibar, okay, in Bangalore on the ground, okay, then you'll
Yes,
have to
sir.
normalize it by adding a plus rho gh, because plus rho gh is the additional thing if Bangalore was at sea level.
Okay,
So
sir.
that you have to account for that 900 meters difference. Okay, because
Oh,
if you don't do that, then you will not be able to get the right information about pressure.
okay, sir. So in the tabs and all, they are showing it with respect to mean sea level only. They are
Correct,
adding
correct.
plus. Okay, sir.
Everything is normalized to mean sea level. All the apps show the pressure at mean sea level.
But actually, the pressure is lower there. So
Actually, the pressure is lower because warm air. So one of these things could have happened because
yes,
warm air
sir.
could have moved in, moisture could have moved in. There could be a trough. There could have been an upper level divergence in Bangalore at upper levels. So one of these things is a sign of an approaching low pressure.
Because in Madurai, I observed, sir. In Chennai, it showed 1014 in my watch, and in Madurai, it showed just 1000. I think it's due to the height, I think, sir.
No. So yeah. So I don't know. Your watch could have been. It's not normalized, right? Yeah. So yeah.
Yes, sir. It's not normalized.
Correct. So don't depend on those kind of things is what I'm trying to say. So don't depend on your phone. Phone will also show pressure. Some of these smartphones have the capability to show because they have a barometer inbuilt. Some of the phones, not all of them. So you can actually get the
Okay, sir.
pressure. They are not normalized. So they just give you the actual pressure at that location. You have to normalize it to mean sea level. Then only you will actually be able to tell patterns.
Okay, sir.
Okay. So before I move to winds, I hope the concept of pressure is clear. If there are any doubts, I would be happy to answer them. Okay, so next comes as winds. So movement of wind is very important. I don't have to kind of tell you again and again. How to read wind charts? There are these lines and there is this circle at in the front. So what this basically means is this is a wind coming from north to south. Okay, so so wherever this circle is there, that is denoting the direction to which it is blowing. Okay, so and these values, so each of these lines are 5 knots. So this is basically wind blowing at 15 knots. This is also wind blowing from northwest to southeast at a speed of 15 knots. This is west to east. So this is a westerly wind blowing at 15 knots. So this is how you actually tell the speed of the wind and the direction of the wind. Okay. 15 knots can be converted into kilometers per hour. It's, I think, 1.8. It's the conversion. So 15 knots is approximately 30 kilometers per hour is the wind speed. So this is how you actually read a wind chart. So you see here. So some of the wind charts, what they will do is they will not have this circle in the front. So what this means is just look for this line. That line means this is blowing from west to east. So this is a westerly wind pattern. So this circle is missing, but that doesn't matter because whatever is indicated at this at the end is that is enough. So this is the tail of the wind and this is the head of the wind. So moving from west to east, and this is 10 sorry, yeah, 10 knots, and this is 5 knots and all these things. Okay, and as you can see, winds, so these are again this is 500 millibar level. Okay, and I see a low pressure which is seen here. Okay, so winds can also be a surrogate proxy for a low pressure system. Okay, so you can actually see winds as a proxy for low pressure system. So this is just I'm showing how wind charts are presented and how to read them. So these are easterly winds and these are westerly winds. Okay, so now talking about winds in low pressure and high pressure, wind motion. So this is a very important aspect because how the wind moves actually determines whether there is going to be convergence or whether there is going to be divergence. Okay, because if there is convergence, then only the air parcels will rise up. As the air parcels rise up, they condense and they lead to formation of clouds. Whereas the other way is not possible because as the parcel is coming from up to down, then that means that it is getting heated up and it is not going to form clouds. Okay, so this is the conducive scenario for formation of clouds, and for that the winds have to move in an anti-clockwise motion. Okay, so this is only true for northern hemisphere. So southern hemisphere is the opposite of this. So whatever I am showing here is only for northern hemisphere. If you want to extend it to southern hemisphere, then you just have to flip it. So it's opposite of that. So in the northern hemisphere, anti-clockwise motion of winds is low pressure. In southern hemisphere, clockwise motion of the winds is low pressure. Okay, so that is what I want to kind of please get that in your head. And what for the rest of this presentation, we'll only talk about northern hemisphere because that is where we are interested in. If you talk about India, it's in northern hemisphere. So I am only interested in the wind pattern for northern hemisphere. So the motion of the winds, which is anti-clockwise, okay, that anti-clockwise motion of winds is what is going to give me a low pressure because it is going to initiate convergence. Okay, clockwise motion of winds is high pressure. Right. So this please keep in mind. And anti-clockwise motion of winds in the northern hemisphere is also known as a cyclonic system or a cyclonic motion. Okay. Cyclonic motion means the wind movement and the rotation of the earth are in the same direction. Okay, so in the northern hemisphere, the wind motion is anti-clockwise, and if you look at from a stationary frame of reference, if you look at the rotation of the earth, that is also anti-clockwise. Okay, so let us not get into technicalities. Let us just keep it simple and say that anti-clockwise motion of winds is low pressure. Okay, and anti-clockwise motion means cyclonic winds in northern hemisphere. Clockwise motion of winds is high pressure, and that means anticyclonic. So you read about these terms: cyclonic, anticyclonic. Anticyclone has settled over India. Cyclone has settled over India. What do they mean? They basically specify the direction of the winds. So anticyclone over central India means that clockwise motion of winds has settled over central India. Okay, that's what it means. All right. So then you have trough and ridges. This is also what I've talked about. See, sometimes what happens is you don't see a very organized system. You don't see very organized wind patterns. Okay. See, when you see a very organized wind pattern, then it is very clear that it's a low pressure system. Okay, and it's good for everyone, right? But sometimes what happens is you don't see a very organized wind pattern, and what you see is actually you see these ups and downs in the winds. Okay, so these ups and downs don't connect. Okay, they just keep moving in a kind of a undulated manner. Okay, so this up and down motion of the winds is what I call trough and ridges. Okay, a trough is nothing but let us understand what is a trough and what is a ridge. So a trough is nothing but the wind as it is moving. Okay, as it moves down and as it moves up, I imaginarily connect this wind and I see what if I loop this around. Okay, if I loop this particular wind pattern around, what kind of motion I am getting? It is a anti-clockwise motion, correct? So although the wind is blowing like this, let me just loop it around. Okay, if I imaginarily loop it around or hypothetically loop it around, then I see that it is forming a anti-clockwise motion of winds, which means that it is a pseudo low pressure. Okay, it has tendency for convergence and updraft of air parcel, which is going to lead to formation of clouds. So a trough is nothing but something that induces a cyclonic motion or an anti-clockwise motion. See, so when I use these words interchangeably, cyclonic, anti-clockwise, that those means the same thing. Okay, so from now on, I'm just going to use the word cyclonic. Okay, so automatically understand that for northern hemisphere, cyclonic means it is anti-clockwise. Okay, so this cyclonic pattern, induction of a cyclonic pattern is what I call as a trough. Okay, and induction of an anticyclonic pattern is what I call as a ridge. Okay, so a wind moving from west to east, a westerly wind will always have a trough which is dipping down and a ridge which is moving up, because dipping down is going to create this induce a cyclonic wind pattern. Okay, and this dipping pattern is very important because what happens in regions of troughs is these wind speed increases, so they lead to deposition of vorticity, and vorticity actually is very useful because they help in convergence of moisture and that moisture is what is getting updrafted. Okay, so this concept is very similar to a ice skater spinning. So when the ice skater puts her arms out, she spins slower because of the conservation of angular momentum. As soon as this, I mean, this is something that all of us see. But as soon as she brings her arms in, she will spin faster. So this faster motion of the winds will actually lead to convergence of moisture. Okay. So what I'm going to talk about is trough. Sorry, it should be trough, not tough. Trough and circulation. So that whenever you see a wind chart, you can either see a trough kind of a pattern, which is this, or you can actually see a full circulation, which is organized circulation. Both of them are actually very useful because they lead to high. So these red portions are high deposition of vorticity. Okay, very high deposition of vorticity, which actually lead to formation of very intense cloud bands. During monsoon season, these kind of trough patterns are highly visible, and you can see west coast of India getting massive rains, not because of a organized circulation, but because of a trough kind of a pattern. Here I want to make one disclaimer that I said that the trough axis, so trough means for all of us, the definition of a trough means something dipping down. Okay, but in a meteorological term, a trough means something which induces a cyclonic motion. Correct? That's what I said. So for a westerly wave, for a wind moving from west to east, the trough will be created, which is a dipping pattern because it induces a cyclonic motion. But this is something that people from Chennai or the people who actually track northeast monsoon will appreciate, because so during northeast monsoon the winds change from west to east to west, correct? So when the winds are blowing from east to west, then the definition of trough changes, because now the upward motion of wind is what is going to give me a cyclonic circulation. So if I take this and if I complete the curve, hypothetically if I complete the motion, then this is the cyclonic motion. Okay, so I am on the lookout for these kind of patterns when I look for northeast monsoon, whereas for southwest monsoon I am on the lookout for this kind of a pattern. Okay, so yeah, I'm not getting into prediction yet. I'm just talking about the patterns of wind, because some patterns of wind actually help us in understanding weather in a much better manner, which kind of connects me to the first question that Kalyana Sundaram asked: weather is unpredictable, reliability is low. But if you actually understand these kind of mechanisms, then and not just believe in the models, then actually the predictability is not that low. Reliability is actually not that low. Okay, so these are the important dynamical aspects that one has to understand, because if you understand what is a trough, then you can be on the lookout for it. And if you understand what that trough actually signifies, then you can actually appreciate the difference between a trough which is forming during a southwest monsoon season and a trough that is forming during a northeast monsoon season. Although they have the same mechanism, but the patterns are very different. Okay. All right. So that is what is the important. I mean, so we have not covered winds yet, but those are some important patterns of wind that I wanted to discuss. Okay. Now, when you talk about winds, you just don't look at surface winds. Okay, because just like pressure, I was just happy with looking at pressure at the surface. But if you're actually doing prediction with winds, then you actually have to look at all the 6 wind patterns, which are surface, 925 millibar, 850 millibar, 700 millibar, 500 millibar, and 300 millibar. Then only you can actually get a very good idea of what is happening. Okay. All right. So surface level winds. Sorry, is there any question? I'm sorry. I think.
Sir, can you please share that wind trough pattern for southwest monsoon once again, sir?
Yeah, this one. This is the wind trough pattern for southwest monsoon, because if I this is not a complete circulation cell like this, but if I kind of hypothetically complete it, then it is giving me a cyclonic motion, which is a anti-clockwise motion for northern hemisphere, which is what is dangerous because it leads to formation of clouds and induction of moisture, which leads to formation of dense clouds.
So for northeast monsoon, the trough should go northward and like it's opposite to southwest monsoon, no, sir?
Correct. Correct.
Okay, sir.
Okay, so surface level winds are again useful because they tell me where winds meet, because meeting of winds means that it is going to create a confluence or convergence, whereas moving away of winds is basically a divergence. This is the first step in weather forecasting because you want to look for converging, diverging patterns. Okay. Other importance of surface winds is that it can be obtained at multiple levels because again you can install it on the ground. Okay. Usually the winds are very weak at the surface because you have friction from a lot of buildings, yeah, mountains, and all these structures, topographical structures. But still, surface level winds can actually help us in giving advection patterns. Where is the warm air and where is the cold air coming in from? So, for instance, if a wind is blowing from sea to land, that means it's a colder wind because the sea breeze is usually colder. Whereas if so, I'm on the lookout for whether the wind is blowing from sea to land or it is moving from land to sea. Because if the winds are moving from sea to land, the low level winds or the surface level winds are moving from sea to land, then it has a tendency to bring in the moisture and it can lead to formation of clouds. This is what happens during thunderstorms. Okay, so we will talk about thunderstorms because those are one of the most important, but at the same time elusive patterns which we are not able to predict yet. But if we kind of get a good idea of these wind patterns, then maybe we can predict them. Okay, so you're on the lookout for these patterns because you want to look out for these fronts, which are the front is nothing but the line between cold and warm air. That is what is a front, and we will discuss this in detail in the upcoming slides. Okay. And surface level wind pattern also tells me whether it is high pressure or low pressure because I go back to this slide. Yeah. So the motion of the winds will tell me whether a low pressure is there or high pressure is there. Okay. So whether the winds are clockwise or anti-clockwise will tell me whether a low pressure is forming or a high pressure is forming. Okay.
Can I ask a quick question?
Yes, please.
So, you earlier mentioned winds at different levels. Now, say, assuming there is a wind that is, there is wind that is blowing at 850 MB, right?
Yeah.
That at different points will not be at the same altitude, right, from the surface of the Earth.
Which is not at the same altitude. Please say that again. I'm sorry.
So, say there is wind. Say if you look at wind blowing at 850 MB on a weather chart.
Hmm.
See, depending on the atmospheric pressure, that would not be at the same altitude, right? Like it would not be showing it for a particular altitude because 850 MB, the pressure line.
Right, correct. It is not. It's not going to be at the same altitude, right?
Okay, that was my question.
Yeah. It cannot be correct. 850 millibar is the pressure we are talking about. It could be at different altitudes for different regions.
Okay, thank you.
Yeah, so this is the typical surface level wind with isobars. So of course, see, it is not well populated because you have a lot of pressure measuring stations, but you don't have many wind measuring stations, and that's why the wind we have only very sparse wind data. All right, so this is one of the limitations of observations because you don't have a lot of information available at every point. Okay, that's the one of the limitations. So 925 millibar, it's at 800 meters from the surface approximately. Again, what you do is you check for these convergence and divergence kind of patterns. You can skip the 925 millibar level. That's not very crucial. Okay, so from surface you can directly go to 850 millibar level. Very important level. So any meteorologist, if you ask him, just like if you say which pressure chart he or she wants, I would always ask for only two, which is 1000 millibar and 500 millibar level pressure charts. Similarly, if somebody asks you what wind level you want, I would go for 850 millibar because that is where the boundary layer ends. In the sense that boundary layer ends means the effect of friction ends, and that is where you can actually start seeing some clean weather patterns. Okay, some clean means without the topography effect or without the building effects or those kind of things. Okay, what do I look for in 850 millibar? What do I look for is I look for these circulatory patterns. I look for the trough kind of patterns, whether the wind is dipping down or not. So if you see here, this is for 12th, and you see that the wind, so this is northeast monsoon season is very active now, but you don't see it. You see that the westerly winds are moving almost in a straight pattern, and there is no like troughing of these winds. Okay, that's why around this 11th and 12th of December, there was not much activity in terms of northeast monsoon. Okay, because you didn't see this, you don't see this kind of a pattern. Okay, so if you look at the winds, this westerly winds, okay, what you see is you see these winds are blowing straight. As they blow straight, they don't do much. They don't lead to formation of clouds. Okay, so what I'm looking for is I'm looking for trough kind of patterns, or I'm looking for the circulatory kind of patterns, which is the low pressure which formed in the Arabian Sea, which gave unseasonal rains to parts of Maharashtra and Gujarat, okay, and even Goa. I'm looking for these kind of patterns, and at 850 millibar, I can actually see these clean patterns. Okay, and the other thing that I'm looking at is convergence. So frontal systems. I'll talk about frontal systems when we talk about processes. But frontal system is nothing but you see that the winds from the sea and the winds from the land, they meet. As they meet, they are going to create a front, and those fronts are actually very capable of giving good rains. Okay, so so 850 millibar, I'm on the lookout for these kind of patterns, which is circulatory patterns, trough patterns, and the frontal patterns, the fronts which are forming. 700 millibar is important because this is the steering wind level. So what happens is at 700 millibar, the direction of the winds will tell me where the clouds bands are going to move, in which direction the cloud bands are going to move. Okay, so 850 millibar, let us say the clouds have formed in the Arabian Sea, and 700 millibar level is going to help me in understanding whether the the cloud bands are going to push inlands or whether they are going to push away. So this clearly tells me that the cloud bands are going to get pushed inland and not in this direction, west direction, but kind of southwesterly, because it's a southwesterly wind pattern at 700 millibar level. So 700 millibar level, I usually use it as a steering pattern. So to see where these cloud bands that are going to form, where will they steer? The other importance of 700 millibar is moisture convergence, because 700 millibar is around 3 kilometers, and that is where the base of the cloud forms. So base of the cloud is on a usual typical monsoon clouds, or even cumulonimbus clouds, thunderstorm clouds. 700 millibar is the level where the clouds actually start to form, the base of the cloud, and then they expand all the way to 10 kilometers, 12 kilometers, depending on the type of the cloud. Cumulonimbuses are very tall clouds, right? So they start at 2-3 kilometers and they go all the way up to 15 kilometers tall, right? So what I'm looking for is I'm looking for the moisture convergence. So at 700 millibar, wherever this blue is, that means there is a lot of moisture getting deposited. So you see 11th and 12th of December, a lot of moisture was there in the Arabian Sea and parts of Maharashtra and Gujarat. And as 15, 16th is getting clearer. So that's why we have warm weather right now, because there's no moisture that is being attracted. Only South India there is moisture, which is because of the northeast monsoon phase. Okay, so I will tell you where these charts you can get from. I'll give a full tour of where these charts are available tomorrow in the hands-on session. Right now, let us just understand what is the importance of each level. Okay. Then comes 500 millibar wind level. 500 millibar wind level are used for two things. One is to find regions of very high vorticity. I already told you the importance of vorticity. Vorticity at high levels means that strong moisture updraft. So very strong. So vorticity is basically so you must have seen this in ocean. There is a vortex which is forming, or we also call it as a whirlpool. What it does is it kind of sucks things inwards, correct? So that is what a vortex does. A vortex is a region which kind of sucks things in. So when there is a region of very high vorticity, it will allow for a lot of these moisture to come inwards, and it will help aid in the formation of clouds. Okay, so I look for regions of high vorticity. Then I look for fast moving stream of air, which I call jet streams. Then I also look at these instabilities. I already talked about this instability. When the winds dip down, that trough, that actually means that cold air is moving down, that can trigger an instability. So the last two becomes very important during winter season. Okay, so 500 millibar level, I don't look at the 500 millibar level during monsoon season because it doesn't help me that much. But during the winter season or during the kind of the post monsoon transition season, it helps me because it tells me a lot of information about whether the cold air is moving down. Because if the cold air moves down, then it has chances of bringing cold weather along with it. Or it also tells me whether it can create unseasonal thunderstorms or unseasonal rains. Okay, so 500 millibar level, I usually don't look at this level during monsoon season. I usually look at this only during the winter season because it tells me a lot of things about jet stream. We will talk about jet stream in detail in today's afternoon session or tomorrow morning session. But jet streams are very important aspects. So yeah, so what happens is during winter time the jet streams moves down, and this is that. So this is a fast pocket. So this is a fast moving stream of air, which has capability to deposit a lot of vorticity, and that can actually lead to some sudden change in the weather, either unseasonal cold weather or unseasonal winter rain, which is possible. So you can see that the jet stream is very active over North India, and that's why over North India you are seeing very chilled weather. And if you want to get this weather down, let's say in central India, then this blue patch has to move down. Unless that happens, we will not get below normal winter temperature. Okay, right now the temperatures in central India and parts of Maharashtra are kind of normal to slightly above normal. So the reason is because the jet stream is not it's not dipping down. It has to dip down to low levels, then only you will see a very cold level, because the air at this level is colder, almost 0 degrees. Okay, so what happens is as it dips down, then it creates an instability, and that pool of air can move to lower levels. Okay, that lower level air can be very cold, and that is what gives rise to these winter chills. Okay. So I just wanted to show. So this is from windy.com chart. The reason I took windy.com is because IMD only gives it for Indian Ocean region. But if you actually are interested in tracking the entire jet stream, then this is the global jet stream which is being shown. Okay, so you can see this. This is a very fast moving. This is a very cold air here, and when you come to India, the jet stream is very active over North India, but not so much active over Central India. That's why winter temperatures are not very chill right now for Central India. But maybe end of this month, it's a possibility that we may. So next week the jet stream is going to move up. So that means the warmer weather will be back to Central India and also Maharashtra. But end of the month, the jet stream may dip down, and the lowering of the jet stream is very important for bringing cold weather. Okay, so so the last level is 300 millibar. It's a very important level because jet streams can be found at two different levels, 300 and 500. So 300 millibar and 500 millibar level are kind of interconnected because you have two different types of jet stream. One is polar jet stream and another is subtropical jet stream. So for a tropical country like India, the subtropical jet stream is what is very important. But then the subtropical jet stream is kind of connected with the polar jet stream, which actually exists at 300 millibar level. Okay, so this 300 millibar level winds actually tells a lot of information because again they dip down or move up, and they bring a lot of winter storms. Correct. This level of 300 millibar is also important because I look for these undulations in the jet stream that lead to formation of a polar vortex, and that polar vortex movement becomes important because if that polar vortex moves to lower levels, then it can cause a lot of unseasonal rains, which we call as western disturbance for North India. Okay, so 300 millibar level is the actual jet stream, but the signature of that is available at 500 millibar level as well. So you can see that this is a typical 300 millibar level, and the jet stream has kind of dipped all the way to North India. That's why North India it's very cold right now, almost 4 degrees below normal, if I'm right. Okay, so let us wrap up the wind charts. It is surface level winds helps me in finding confluence zone. 850 millibar winds is the wind that I actually see to see the formation of fronts or warm air and cold air advection, because that is going to tell me whether it is going to lead to formation of clouds or not. 700 millibar level is used for steering. So once the clouds have formed, where are they going to move? Which direction are they going to move? 500 millibar level is used to find the regions of vorticity and associated instability. And 300 millibar is the jet stream and polar vortex. Okay. So these are the wind. When it comes to winds during the monsoon season, surface level 850 millibar and 700 millibar are the key wind levels that one should see. That can actually tell you a lot of information. During winter season, we should see the 500 millibar and 300 millibar level. Okay, so any doubts before we move ahead? Okay, so we are moving a little bit slower than expected, but I guess it's okay. So let me just change the background because we are going to talk about temperature. All right, so temperature is very important because you have. We all know that as we move up, temperature reduces. It's usually warmer on the ground, and as you move up, it decreases. And as the warm air moves up, then you start creating these convective patterns. Okay, and the convective patterns, the clean signature of these convective patterns is seen at 850 millibar, and that's why I said that 850 millibar is very important. Some signature of the temperature, cold. So warm air. So there are two things when you talk about temperature. One is warm air rising up. The other is cold air from the top moving down. So the cold air from the top moving down happens during winter season, which actually leads to instabilities, and that leads to the that has the tendency to form these thunderstorms that we talked about, okay, or winter rain that we talked about. So what is the one important cause of convection is the high ocean temperature. So whenever I talk about temperature, I don't care about the temperature of the land. I mostly care about the temperature of the ocean, because that is where the moisture is going to come from. Okay. So when you talk about the temperature, there is a small tidbit that I want to give. It is widely accepted that when the ocean surface temperature, or the SST, sea surface temperature, reaches a magic value of 28 degrees, then only the convection can start in the atmosphere. So that 28 degrees, how they, so it is not something that has come from models. This 28 degrees has come from observations over various different oceans. So people have taken observations from every ocean, be it Indian Ocean, Pacific, or Atlantic. And they have actually seen, and they have done a lot of statistical analysis, and they have seen that 28 degrees is the magic value for the convection to start. How the atmosphere and ocean know that is amazing, because as soon as the ocean reaches this 28 degrees, it's like a thermostat. It switches on and it starts interacting with atmosphere, and it starts creating these convective patterns. And once convection starts, that means the low pressure is highly likely to form. Okay. This is the reason why atmosphere and ocean have to be modeled together. We cannot just look at atmosphere as a standalone system. Because the boundaries are seamless in the sense that there are no boundaries. So ocean and atmosphere interact with each other. That's why the temperature of the ocean is a very, very important aspect. Okay. And this 28 degrees has been found from a lot of observation that people have done. And we still don't know why this magic value of 28 degrees is that. Why is it not 27, or why is it not 29? Why is it 28? So there is no answer for that. Okay. But the good thing is that at least we know that when we look for these 28 degrees values of temperature in the ocean, these are the hotspots for creation of storms. Okay. And that is why your Bay of Bengal and Arabian Sea are usually in an elevated state. See, so Arabian Sea was not at an elevated state if you see the last decade or so. Arabian Sea was usually at a very low temperature. But over the years, Arabian Sea has warmed up. So Bay of Bengal is always known to be a very ferocious basin. The Arabian Sea was not so ferocious. But over the years, Arabian Sea has also warmed up. And most of the time, you see temperatures which are greater than 28 degrees Celsius in Bay of Bengal and Arabian Sea. And that is why our Indian Ocean is always active. So only the dormant period is January and February. Other than that, if you look at starting from March, your pre-monsoon season starts, then your monsoon season, then your post-monsoon season. Then you have the northeast monsoon season. So your entire year is kind of occupied with storms, and there is no respite, right? The reason is because both of them, you look at a kind of a statistical average of these temperature values of Bay of Bengal and Arabian Sea. 28 and above is 95% of the time you will see that the ocean temperature is more than 28. And that is one of the reasons why you have very active systems forming and moving towards the land. Moisture is one of the important aspects. I don't need to elaborate. Ocean is the main source of moisture. 70 to 80% of the moisture comes from the ocean. So the movement of the wind from ocean to land is very important, and the formation of a low pressure over ocean is very important. And one thing that all of you should understand is the formation of low pressure over ocean is the one that actually is disastrous most of the time. Low pressure over land is not that disastrous because it will not give to very, very heavy rainfall. It will just give moderate to heavy rains, and not for a longer period of time because of friction. But ocean, low pressure is something that if we watch out for, because that has the capacity to become into a very intense system. Okay. Coriolis effect. What is the importance of Coriolis effect? The Coriolis effect importance is that it helps in deflection. So automatically the parcels would spin. So because our Earth is rotating, there's automatic spinning, which kind of leads to formation of vorticity. Okay. So even if the system is not curving, Coriolis effect will ensure that it curves and leads to formation of some system or some moderate to strong system. Okay. So Coriolis effect is kind of the thing that you cannot deny. It's always there. Okay, so can we maybe if there are questions I can take. I will maybe take a 1 minute if you have any questions or clarification or suggestions. If you want to add anything, more than happy to leave the floor to you guys for some time.
Hello.
Yes, hello?
Yeah, I have a small doubt. So you said that the temperature of the Arabian Sea has been rising over the past few years. So is that because of climate change and global warming?
Mostly yes, mostly because of that. Because so there is an aspect of why the oceans will warm up. I have an aspect of that when I talk about solar insolation. So the only source of so if you release more heat, then the only source of the only sink is the ocean. So the global warming and climate change are the reason for the Arabian Sea to have warmed up over the past few years. Yes.
Okay, cool.
Yeah.
Sir,
I have a slide. I have a small section which talks about why we should be ready to face more extremes as we move into the future climate scenario. Yeah. Yes, somebody has.
sir, yes, sir. Sir, how are the extra tropical cyclones forming, sir? Because near that Ireland and all, temperature is very low. Sea surface temperature is
Yeah,
low,
we'll talk about
but
that.
it's giving snow also. Yes.
That is because of jet streams. We'll talk about that. Where there is a separate module on that.
Okay, sir.
Yeah, extra tropical storms. I have a separate module which I will discuss. Maybe not afternoon or maybe tomorrow morning. Okay.
Sir, this is Makaran. I got a question. The jet streams that you mentioned about, do they basically they become active only during winter, or they sort of really keep flowing all the time?
So they keep flowing all the time, but then they become active. They start undulating after. So for Indian region, they become active only during the winter. So there is a reason for that. The reason is because we have the monsoon season. So during the monsoon season, the jet stream moves. So we have to understand that during the summertime, the jet stream moves upward, moves much northern. So let us say the location of the jet stream is 30 degrees. So during summertime, the jet stream is pushed to 60 degrees or 70 degrees. Okay, and then winter time is when it starts moving down again. From 30 degree, it can come down to 20 degrees. Okay.
So the source of the jet stream is essentially the poles, right? Both the poles or only the north pole?
No, so the source of the jet stream is actually the heating, the differential in the heating between the equator and the poles. So the jet stream forms near the polar region, okay? But the source of the source of jet stream is mainly because of the differential in the heating between equator and pole. And as this difference keeps on decreasing, then the jet streams actually have the tendency to undulate more and move further south.
Yeah.
So I will. So there is a separate topic on jet streams which I have. Okay, we will. I think maybe we'll talk about that at that time. Or if if everybody's interested, we can move to that module now. Or after we can have a 5-minute break and then we can go to that. But it's better that we wait maybe because it will. Because if you, I mean, there will be a flow. Rather than kind of disrupting it, I can do it later. The jet stream aspect. There is a separate there are separate slides on jet streams, so that may clarify your doubts.
Yeah. I think I don't know. You should change your pattern. I think you just stick to that.
Okay.
I mean, I just had this question on top of my mind. So you stick to your schedule. That's perfect for me.
So jet stream actually, so in poles the jet stream is always moving, but when it comes to the tropical region, the jet stream is active not during the summer; it's active only during the winter, and there is a very strong reason for that. It's because of monsoon. The monsoon systems don't allow the jet stream to penetrate down. Once the monsoon system starts moving down, so once the withdrawal starts happening, then the jet streams actually start moving down. Okay. Right. And the onset of monsoon is also highly related to when the jet stream starts moving up again. Because unless the jet stream starts moving up again, your monsoon currents cannot push. Right. Cannot move up. So it's a very nice synergy. Like there is a very interesting synergy between jet streams and the monsoon currents. Because unless and until your jet streams move up, your monsoon currents cannot penetrate. And unless and until your monsoon system moves down, the winter is getting delayed and delayed. Your winters will get delayed. Yeah, that's a very interesting synergy. I think we can talk about it when we discuss the jet streams.
Yeah. Thank you.
So maybe we can take a 5-minute break and then come back. Yeah. Is that okay with all of you? So that we can too much of these techniques.